In the last episode, we looked at debugging rover's crash, and there were two main culprits. There was a few more, but there were two main culprits. One was the buffering in the roboclaw, the motor controllers, and the other was the sensor anomalies. I had the buffering issue addressed, and I think I now have a solution for the anomalies in the sensors. And let me show you that before we get rover started down another autonomous test drive.
Send over a command to rover to turn on his forward sensors. We're going to see the output here in the serial monitor, and you can see the values here. Basically, we're taking the maximum value of 4 separate values, and what I'm going to do is just going to run my hand closer and closer to the front left sensor. We see these numbers going down, and what I want to show you is a particular quirk. Perfect. So here we see a perfect example of how this smoothing is working. We got a few kind of really quirky anomalies here with values of 2 and 3 in some situations, but we see the value that was actually passed is more representative of the distance to my hand was to the sensor. The 18 value was pretty consistent, even though we got these anomalies of 2s and 3s. So this approach should work.
So if we think of the different sensor readings, the 4 values that we're taking as being a scatter plot, and then once in a while we get these super low values. Equally, we can get sometimes super high values. Basically what we're taking is we're kind of smoothing it out in a way, and we're taking the upper end of the value and we're ignoring these lower values, especially the anomalies that might trigger our programming. Getting ready for rover's second attempt at the autonomous test drive down the hallway. I've been testing and retesting as much as I possibly could, and I've come to the conclusion that I can't even think of every possible foreseeable circumstance. There are just too many variables and too many possible ways in which things will come together. There are quite a few that I've come to recognize that are likely to be problems in rover's attempt. He might fail because of one of those things, or he might fail because of stuff I haven't even thought of. So what you're looking at here is a rough sketch of how rover will, in theory, or at least in an ideal scenario, how he would navigate down the hallway and out to freedom, the front door to my condo. So the first step will be to encounter the wall in the kitchen. He'll then back up, rotate his servos, proceed right after straightening out his wheels, and then encounter the wall here before rotating away from the right obstacle. Then we'll continue down until he reaches the final wall at the end of the hallway. He would back up again, rotate his servos, and proceed right. The first issue that I have is I don't know how much he needs to reverse in order to kind of give himself enough clearance from the obstacle that he encounters. So the first thing we basically need to test is how far back he needs to reverse and how much we need to have him drive with his wheels orientated for a turn in order for him to be situated in a way that allows him to actually move away from an obstacle successfully. Okay, so what we're going to have him do is I'm going to basically just have him drive forward. We're going to actually send over the hallway program. I'm going to block his sensor before he gets anywhere close to the wall, and then we'll see how it actually works in reality, what we've got programmed thus far, to see how much of a turn his settings currently actually result in. I need to figure out whether we want him to reverse and kind of be situated at a 45-degree angle to the obstacle he encountered, or whether we want a full 90-degree turn. I don't know how things look and what the reality kind of warrants, but let's give it a shot and see what happens.
Okay, so let's send over the hallway program here, and then I'm going to run over to rover and block his sensor before he gets going, and let's take a look at what his turn commands and what they actually look like in real life.
Forward obstacle.
Okay, so what we can see is that he's not quite 45 degrees, but basically the commands that we have resulted in, I would say, I don't know, maybe 30-degree turn. I don't know how good or how bad that is and whether or not we want more of a turn, but let's take a look at how that actually looks in the command center and reevaluate.
So here we're looking at the command center. Let's do a couple of refreshes. So here's the first drive command that we sent over, this one here, the 4360. He then encountered a forward obstacle. He identified it as the forward center obstacle. We heard him speak. He then reversed and then initiated his servo turns. So basically he rotated his servos, as we saw, away from the obstacle towards the right. He then drove forward with his servos orientated away from the obstacle, kind of in the turn orientation. And then he re-straightened his servos into the wide orientation. And finally, he turned off his motor. So that's how it actually came together in terms of the sequence of commands. So basically, in order to have ROVer turn more, let's say if what he did was a 30-degree turn, if we want him to turn more, then basically we need him to drive more after this turn, so this step here, which we can do by varying the program. So if we go to the program, so this is where he drives forward. He then encounters an obstacle, which is this 10,001 ID code. What we want him to do is drive a little bit more, probably. So instead of 3,000, we may want, I don't know, let's try 5,000. So that's been saved now, and we can give it another try. I also didn't have the 24-volt turbocharger on. We'll want to try that setting on as well, and give it another go.
So I've positioned this storage box here just to give us a movable object, because I suspect that ROVer is going to actually hit it, because I probably have to tweak the sensor sensitivity. Right now I have them set at about this distance here, but I think that isn't actually a practical value or distance when he's actually rolling forward, because he has momentum, and it takes a few fractions of a second for him to actually process that information before he actually does come to an actual stop. So the actual point at which we want those sensors to trigger might be somewhere farther away. I'm not sure, but it's a bit of trial and error until we figure that out.
So I'm going to start off by aligning all his wheels straight. So I'm going to send that over to ROVer, update his settings so that we're using the turbocharger, and then finally we'll initiate the hallway drive command. So let's send that over and see what happens.
Well, he definitely hit it.
Forward obstacle.
No kidding. Okay, so the reverse command was way too little, because he didn't even get away from the obstacle.
And what I'm going to do is I'm going to update the initial drive command so that let's double it to 20,000. So let's do 10,000 forward. That'll almost certainly have him encounter the storage bin. And his reverse is set at 3,000. And then his forward drive with after the turn is set at 5,000. So let's just see how that looks like, and send that over to ROVer.
Forward obstacle.
Now we're looking for ROVer to back up. This is the 10,000 value. Now he's going to rotate right, and then he's going to roll forward. So he's just finishing up his servo rotation, and now he's going to roll forward. And I want to see how that angle compares with where he was before. So now he's straightening out his wheels again. So here's basically the angle at which ROVer encountered the obstacle, and that's the angle.
Excuse me.
And that's the angle that he is now. And as he rolled into the obstacle a second time, it triggered yet another response, and that's what he's doing now. So basically one thing leads to another, and he's reacting a second time. But basically what I think we want him to do is roll back further, so that he can complete a 45-degree turn for obstacle avoidance.
Robo-claws off.
But as you can see, this is a whole bunch of trial and error. So I think what I'm beginning to appreciate is that the reality of ROVer being on the ground is different than when he's up on his stilts and we're just playing with the sensors with my hand. So basically what I need to do is just kind of play around with exactly what values equate to what distances. And like I said, I want him to be able to react differently to a kind of an obstacle that he encounters at an angle versus one that he encounters straight on, because that's going to matter a lot. Because for example, if we program him in this situation to turn away at a 90-degree angle, ROVer is pretty big. So if he does that in the hallway, he won't have enough room to actually perform that maneuver. So we need a few different ways of orientating him away from obstacles depending on what sensor gets triggered and what combination of sensors get triggered. So with what we've done over the past week in terms of building out ROVer's ability to dynamically respond, he has those capabilities already in the command center. It's really just a matter of figuring out what the settings are for him to properly react to his environment. So I've got a bit of homework, and then we'll try again tomorrow. So if you're as curious to see as I am, how this actually all comes together, subscribe to get notified, give us a thumbs up, use the comments down below on YouTube or over on ROVer's site. We'd love to hear from you, and we'll see you guys next time. Cheers.